children. In the previous video we saw charging by friction method, where we are going to rub the two body with each other, and by actual transfer of electrons from one to another the charging of the body takes place. Now let us see another method, that is charging by conduction. So what do you mean by charging by conduction? Means here we are going to bring a charged body in contact with the another uncharged body. So, or the body to be charged. Say for example, means here what we are doing, here a charged body is brought in contact with the body to be charged. Well, say for example, here I have taken one conducting rod, say a steel rod, which is basically now negatively charged, and this is a body, let me call it as a body A, is to be charged. So now initially the charge on this we are having it as 0, it's a neutral. Now if you just bring this rod in contact with this body A, then we are going to see that the electrons will get transferred to the body A, means it starts getting negatively charged. But suppose if I take this, after bringing in contact for a while, if I take the rod away, then we are going to see that these transferred electrons will get equally distributed on the surface of a conductor. Okay, so now it is totally negatively charged. So we got it as negatively charged. This is how we are going to carry out the by conduction method. So here what we are observing, the first and foremost, the method is by bringing a charged body in contact with the uncharged body. The second thing is here the transfer of electrons takes place, or sharing of charges takes place, I can say. Whereas here we are seeing both of them are likely charged. So if I call this as body B, we are seeing that the nature of the charge on A as well as B, so both are going to be the same. Okay, whereas in friction we had opposite nature. Okay, now of course, since sharing of charges takes place, there must be variation in the mass also. So glass rod is going to lose its mass, whereas this conductor is going to steel rod is going to lose its mass, whereas this conductor is going to gain its mass because of gaining of excess electrons. In this, let us see some special cases. What happens if suppose I have the two conductors which are identical, means of same radius they are. Okay, both radius are same, identical, okay, in size. So if suppose both are of same radius, two conductors, spherical conductors I have taken, and initially they are having charge, both are initially charged itself. Say one is A is having charge minus 5 coulomb and this is having plus 9 coulomb. What happens if I carry out the conduction method? If I bring both of them in contact, and we are going to see that if I keep for a while in contact, again sharing of charges takes place in such a way that if they are identical, we are going to see that both of them they are going to have equal charge after separating, means after conduction they are going to have the equal charge, that is Q dash and Q dash. So condition applies if they are identical. Okay, only in that case. Then how will you find this Q dash? Very simple. We carry out here. Hope you remember I had told you additive nature of charge in the property. So what it says, we can add the charges simply algebraically, but taking nature of charge into consideration. So what is the net charge we are having? Q1 plus Q2. That should be divided now equally. So Q dash is given by what? Q dash is given by Q1 plus Q2 divided by 2. So mathematically when you calculate, Q1 is how much is there? I have to take nature of charge into consideration as per additive nature of charge. So 5 coulomb plus this is 9 coulomb divided by 2. So that becomes the 4 by 2. So hence we are going to get 2 coulomb each. So we are having both of them later. They are going to have, after carrying out conduction method, they are going to have how much? Bringing in contact. So 2 coulomb and 2 coulomb each. So do remember that we have to consider nature of charge even though we are adding like as a scalar quantity algebraically. This is a very important point for you while working numericals under the Coulomb's law. So do remember how to calculate the new charge when you bring a body in contact and separate once again. Now the question comes, second case is, what happens if suppose two conductors are not identical? Now let me take of different radius. One is of small radius and another is of large radius. Now in this case, suppose if it is having initial charge q1, if it is having q2, if I bring them in contact and separate, now you cannot decide. You cannot decide what is going to be the new charge on them unless you have the idea of electrical potential, because same like flow of heat and all you have learnt in the conductors, even here also we are going to observe that the flow of charge will take place from one to another. Now we cannot decide which is at higher potential, which is at lower potential unless we know the charge. Okay, so suppose if I assume A is at higher potential initially, so means VA is suppose greater than VB. So here we represent the potential as by V. Okay, notation. So potential, electrical potential of the A surface is more than electrical potential of the B surface. In that case, the flow of charge takes place from the A body to the B body until both of their potential becomes equal. So both of their electrical potential becomes equal. So what we can conclude here, hope these two cases are clear to solve your numericals. So what we can conclude in the conduction method, here also transfer of charge takes place, means electrons takes place from one body to another body, but nature of charge we are going to observe is same on both of them, and even the one which loses, means the charging body is going to lose its mass, the body which is getting charged will gain its mass if this is a situation, but this depends on the, so which is positively charged, which is negatively charged, but certainly there will be a variation in the mass of both the bodies. Hope everyone is clear with the conduction method. Thank you.